first thing, we need to write it as sine x over cos x. And then somebody said, let's let u be cos x. Okay, so then du would be derivative, yeah, negative sine x dx. So then then I can pretty much replace, does everybody see I can pretty much replace, there is my sine x dx with this. So then I need to put the negative on the other side. So negative du equals sine x dx. Does everybody see that? Yes? So then this will become the integral of the negative integral of 1 over u du. What is that? What is that? That's a natural log. Okay, so, and I think on the other day I said to memorize these things or whatever. Yeah?
At the top, the very top.
Oh, at the very top. Make sure you put it in absolute value, because do you remember what the log graph looks like? Yeah, it looks like this. So you cannot have any negative values in there, and sometimes you might, and that's how you will reject some stuff. So when you're going backwards, you have to make sure to make this. So this is negative log of the absolute value of u. Yes, natural log. Negative natural log of the plus c. Okay, so then this would be negative the natural log of the absolute value of cos x. Right? Because that's what u is, plus c. So once you've seen this once, you can either memorize that that's what it is, which I'm surprised actually, is it on here? Do we have any trig ones on here? There's no tan.
No, there is. It's on the bottom of the trig function. It says secant. Oh, right.
No, yeah, no. Yeah, some books actually make you memorize that, but anyways, you can memorize it or you can, you know, redo it. Okay, so now today we're going to do, and I don't know if you started with the worksheet that was after this lesson or you started with the textbook. If you started with the worksheet, you could only go so far because I never actually showed you how to do definite integrals, right? I only showed you how to do indefinite. Does everybody know the difference between indefinite and definite? Yeah, there's like, yeah, the upper and lower values, right? Okay, so when we do u substitution, the fastest way to do u substitution is when you do this u substitution, you actually change the values, the upper and lower values. Why? Because you either need, and I'm going to show you both ways, but I swear, like, you should just do the one way. I'll show you both ways just so that you know. But does everybody understand this upper and lower has to do with x, not u? So you can't, it's no longer valid once you change it to a u. Okay, so I'm going to show you two methods, and then you can decide, I guess. Method one, ignore values and do indefinite integral. So you're going to do the indefinite integral of this, well, I'll do a brackets, x plus 1 to the power 1/2 dx. So what's u going to be? Yeah, so let u be x plus 1. So du would be dx. Yeah, because the derivative of x is just 1 times. So then this would be the integral of u to the power 1/2 du. Yes? So that would be, add 1, so that is what? 3 over 2. So 2 over 3 u to the power 3 over 2 plus c. So that's 2 over 3 x plus 1 to the power 3 over 2. And then after you do this, you have to integrate it. So then, therefore, the integral from 0 to 3 of the square root of x plus 1 dx is, yeah, there's a plus c, but you'll see in a second because it's a definite integral now, the c's will actually go away. So this would be 2/3 x plus 1 to the power 3 over 2 from 0 to 3. I'm not going to write the c now because it's... So this would be 2 over 3. 3 goes in there. 3 plus 1 is 4. So times 4 to the power 3 over 2. Subtract 2 over 3 times 1 to the power 3 over 2. So the square root of 4 is 2. 2 to the power of 3 is 8. So that is 16 over 3. Subtract 2 over 3. 14 over 3. Okay. I don't like this method at all. It's too much work. But if you forget how to do this or you get stuck somewhere, this is always a default method where you kind of ignore the definite part of it, do it as an indefinite. And so I'm going to do it in a different color pen. Okay. Method 2. As you can see, it's less steps because I only need this much space. Okay. So method 2 is I look at this and I know my u is going to be x plus 1, right? Still the same thing. Du would be dx. But then I rename, instead of 0 to 3, does everybody see that u is going to be whatever your x is plus 1? So if this was 3, this is now going to be 4. And if this is 0, you just make this a 1, and then it would be u to the power half du, right? And so then you don't have to change it back to x because now you're actually evaluating u amounts, right? So this is just going to be bracket 2/3 u to the power 3 over 2 from 1 to 4. As you can see, it's going to be the exact same answer, right? So this is going to be 2 over 3 times 4 to the power 3 over 2. Subtract 2 over 3 times 1 to the power 3 over 2. Square root of 4. Well, it's going to be exactly, at that point, it's exactly the same, right? Yeah? So you get 14 over 3, right? So as you can see, method 2 is way faster. So I highly recommend using method 2. Okay. Now the problem lies is when you have an indefinite integral, will you remember to put it back into x notation? If you're practicing this, you don't put it back into x, right? Do you see where that now you get a little bit of a, you have to remember? Does that make sense? Yeah, so in this method, this still follows the same method that you've always been using for u substitution. You put it back into x, then you solve it. This one, you don't have to because you've renamed this u, so then you don't need to, right? Yeah. So it's up to you. Okay, so let's do the next one. I want to practice method 2 for sure. So what's u going to be in this one? Yeah, so u is going to be 3x minus 1. That was probably your easiest Khan Academy assignment ever, right, is to tell me what u was? You gotta have a freebie there once in a while. du equals 3dx. So I gotta get dx by itself. So that would be 1/3 du equals dx. Yes? So now we're gonna rename this. Instead of 0, it's going to be -1, right? Instead of 3, it's going to be 8. And then it's going to be u to the power 2/3. And now instead of the dx, I have to write the 1/3, which I'll do in front, du. Any questions there? We good? All right. So we add 1 to 2/3 and we get 5/3. So then it's going to be 3 over 5 u to the power 5 over 3, and this is going to be timesing by 1/3. Yes? I'm going to also show you another shortcut. Instead of using the boxes, have you seen this anywhere? Where you just use a vertical line and you just put -1 to 8? Yeah, it does save, anything to save time is worth it, right? So this is another approved notation for it. So does everybody see the 1/3 will cancel there, right? So it's going to be 1/5 times 8 to the power 5/3 subtract 1/5 times 1 to the, sorry, that's a -1, isn't it? -1 to the power 5/3. Are we good? So the cube root of 8 is 2. 2 to the power 5 is 32. So I get 32 over 5. The cube root of -1 is -1. -1 to the power 5 is -1 times 1/5 with a subtraction. That becomes a plus 1/5. Yes? So then we get 33 over 5 as my final answer. Yeah? Okay, do you guys want to try the next one on your own?
Yeah.
All right. Well, why do you need to know it? Once you figure out what u is, it might all come into play, right? Working out all good. Okay, so u equals x squared, du equals 2x dx. So 1/2 du equals x dx, which is that part. So then this would be the integral of sine u, and that becomes a du with a 1/2 in front. And then the intervals, yeah, 0 to pi, right? So the antiderivative of sine, what's wrong? So the antiderivative of sine is minus cos u. This is the one that a lot of people always confuse the sine. So always go backwards. I think most people know the derivative of cos is minus sine, right? So then you know that the integral of sine has to be minus cos. And this is a 1/2 from 0 to pi. So -1/2 cos of pi, subtract negative, so that's plus 1/2 cos of 0. So this is going to be -1/2 times -1 plus 1/2 times 1, which is 1/2 plus 1/2, which gives me 1. This was actually, cos of pi was a reach for the top question, wasn't it? Yesterday. And Josh got it. He better get it. Sometimes they ask it to you this way. Find the area under the curve from y equals that, from 0 to 2. So what does that mean? The integral from 0 to 2 of x square root of 2x squared plus 1 dx. So you want to try this one on your own? No? Okay, u equals 2x squared plus 1 du equals 4x dx. So 1/4 du equals x dx. So that would be 1, and that would be 9, yes? And the x dx is this part of it. So then this is going to be u to the power 1/2 du with a 1/4 in front of it, yes? So then this is going to be 1/4 times, you add 1, so that's 3 over 2. So 2 over 3 u to the power 3 over 2 from 1 to 9. These cross cancel. So you get 1/6 there. So you get 1/6 times 9 to the power 3 over 2. Subtract 1/6 times 1 to the power 3 over 2. Square root of 9 is 3. 3 cubed is 27. 27 over 6, which can be reduced, but minus 1 over 6 is 26 over 6, which is 13 over 3. By the way, you can leave it as 26 over 6. Like, you don't need to reduce it.
Yeah, but is it really bad if you reduce it?
If you reduce it and get it wrong, it's bad.
I mean, you're dividing by 2.
Yeah, you're dividing by 2. It's all odds you'll probably get it right. Okay.
This is the one that's a little...
This was a little crazy, or what?
The last one's easy. This one's
The last one's easy. Oh.
Yeah, compared to the 6, like 6 is way easier.
Okay.
6 is way easier, yes, because you need less steps.
Okay. Try number 6. So u equal 1 plus 1 over x du. So this is 1 plus x to the power negative 1. So du equals negative x to the power negative 2 dx. So this is negative du equals 1 over x squared dx. Yes? So that is that part. By the way, when you do in this course, they're all going to be nice workout like this stuff, right? Like, so don't get scared about, oh, that looks crazy. Anyways, so 1 over 8, and if I reciprocate 1 over 8, I get 8 plus 1 is 9, and this is 4. And then the u to the power a half du with a negative. So then I would just rewrite it as 4 to 9 u to the power half du. And then you don't have to worry about the negative in there, right? So then add 1, you get 3 over 2. So 2 over 3 u to the power 3 over 2 from 4 to 9. So this is 2/3. The square root of, I guess I can just go 9 to the power 3 over 2, subtract 2 over 3. But if this was a multiple choice, you don't have to show all these little steps, right?
I mean, but if you don't, you can make...
You could make a mistake. So, yeah, that's the thing, right? Eh? You can...
Especially when you have so much stuff.
Yeah. Yeah. So this is times 27, and then this is... Square root of 4 is 2, so that's times 8. So 54 over 3 subtract 16 over 3 is 38 over 3. All right, did everybody get a chance to do 7 already?
Yeah.
There's actually 2 ways you can do this. Okay, I'm going to do it probably the way you did it, and I'm going to show you another way because there's going to be some trig ones that come in and you have to play around with it. Okay, so I'm sorry? Okay, so you said let u equal tan x, so du is secant squared x dx, yes? Which is that part. Which makes it really easy, right? So this is now, what is tan of 0? That was another question too. Yeah, 0. And then tan of pi over 4, 1. And this is u du.
Yeah.
How easy is that? So this is 1/2 u to the power 2 from 0 to 1. So this is 1/2 times 1 squared minus 1/2 times 0, which is just 1/2. Okay, so I'm going to show you another way to do this question. And the only reason I'm going to show you it a different way is because sometimes you do have to break things up with these trig ones. So I'm going to go, or I'm going to show you that. And you probably wouldn't have done it this way, but I'm just going to write it like this. Sometimes, I'm just going to show it to you because sometimes you'll come into something where you have to rewrite the square as 2 separate. So now, do you see that I could let u equal secant x, then du would be secant x tan x dx. Do you see? Does everybody see? So there is that part dx, yes? And what is secant of 0? Huh?
1 over 1.
Well, yeah, so 1. So this would be 1. And then pi over 4 Yeah, 2 over root 2.
Oh,
It's not the best way, but I want to show you an alternate way just in case you ever have to think about this, okay? So then you get u du. So this would be 1/2 u to the power squared from 1 to 2 over root 2. More calculations this way. 1/2, and if I square 2 over root 2, I get, hold on a second. Hold on a second. Hold on. 2 over root 2. Cos of pi over is 1 over root 2. Oh, so yeah, it's the same thing. I was going to say it would have been easier to use 1 over root 2, and then if you flip it, it's just root 2. Yeah, which this is the same thing as root 2, right? So I think it is way easier just to write it as root 2. Because when I square it, then it's gone versus, yeah. Sorry, I'm just going to fix this up a little bit. It's okay. Okay, so then this is root of 2 squared is just 2, 1/2. And then you get 1 minus 1/2 is 1/2. Either or, you get 1/2. I'm just showing you, again, a different way. Again, this is not probably the way you would have thought of to do it. But if you ever get stuck in the trig are the hardest ones because sometimes you have to manipulate it different ways. So